Alright, so we've got a flaw to look at. When we did our fast scans, we found that there was a very short flaw. It's located right here, but it's very short. And when I look at this with 45, 60, 70, it didn't look like anything, except from one spot, pretty much with the 60, which really shows us what it is. So we're going to go right to that with our 60. So I recalled the 60. It's got a 2-inch screen range, so it's a 1-inch deep screen. 1 inch deep is here, a 1/2 inch deep is here, and this is the outside surface. And I've gone ahead and we don't have surface distance minus x-phi, we just have sound path surface distance and depth, and we've told it that the material is a 1/2 inch thick. And let's check our cal. This is the 60. So when I peek up on the 100 deep hole, it peaks up near 100. When I peek up on the 2, it peaks up near 2. When I peek up on the 3, it peaks up near 3. When I peek up on the 4, it peaks up near 4. And at this gain setting, I'm just about 50% screen height, which is where I always want to be. So I'm going to enable the reference dB. And let's go ahead and do some scanning over here. As I say, when we use just about anything, from this side, can't really tell anything from this side. From the side we're going to do most of our work on, we can tell that there's a little something going on here. But it's not until we pull way back here that we really see it. That's right on the detection. And that's extremely loud. And it peaks up in the middle of the second leg. And it walks a long, long, long way. It looks like a 70 it walks so far. It's got what we call a fast rise and fall time. Goes up and comes down very quick. And this is all typical of sidewall lack of fusion. And with a 60, you know, you're at, the bevels are at 30, so when you're hitting that with a 60, you're at the perfect angle to be reflecting from that. But I found with this that I could tell pretty much where I thought the center of the flaw was by where it peaks up, but I couldn't find the top of the flaw or the bottom of the flaw with 45, 60, or 70. Now, I've worked on this coupon before, and I know that with FMC TFM, and a little bit with phased array, and certainly with soft, I can do some very nice flaw sizing. But the best I can do with this flaw is just show where it is. So we're going to go ahead and do that. And we're going to do that by peeking up on this. And I want to see where I peek up on it. So I'm going to take some gain out. -6. -6 again, and I'm going to say this is located right about at here. So I'm going to freeze that. And I'm going to measure my surface distance from the index point to the toe of the weld. And I get 1.4 inches. So I'm going to make a note of that. And we've got our other numbers recorded here, so we can jot those down and go ahead and do some flaw plotting, some indication plotting on our TNC. All right, let's see what we can do with our plotting. We're using a 60, and the index point, the distance from the index point to the toe of the weld was 1.4 inches. Let's go ahead and plot that on there. That's where our index point was. Our surface distance is 1.470. The surface distance goes to right about there. And our depth to the flaw is 151. 150, that's going to be right about to there. And our sound path is 1.698 inches. So about 1.7 inches. So I'm going to put the index point right on the mark where it was. And on the 60-degree line, that brings us to right about here. I was just shy of 1 inch of sound path on the 60-degree mark, just shy of 1 inch. And our sound path is going to end at 1.7 inches. 1.25, 1.5, 1.75, so 1.7 right about here. So this all plots up pretty close to being a lack of fusion right there. All right, thanks a lot.